Hello friends, I welcome you all again to my video tutorial. So till now, in my these video tutorials, I have told you about the divisibility rule of 2, 3, 4, 5 and 6, 8 and the further powers of 2. Now I am going to tell you the combined divisibility rule. Seven, 11, so this is what we are going to discuss in this lecture, the combined divisibility rule of 7, 11 and 13. Now the point is that in most of the books you are going to find the divisibility rule of 11. In some books you are going to find the divisibility rule of 7 and 13 also. So those individual divisibility rules of 7, 11 and 13 I am going to tell you after some time. At this point of time, I want to tell you a combined divisibility rule of 7, 11 and 13, which is also called as the cases of triplets. That is the cases of triplets. Sorry. Now, suppose we know that 7, 11 and 13, these three are prime numbers. If I am going to multiply this 7 into 11 into 13, what I am going to get? I am going to get 77 into 13, that is 1001. 7, 11 and 13 are prime numbers. If I am going to multiply 7 into 11 into 13, what I am going to get? Prime number, that is 1001. So 1001 is the multiplication product of 7, 11 and 13. Now, if a number is divisible by 1001, that number will also be divisible by 7, 11 and 13. This is the logic. If a number is divisible by 1001, that number will also be divisible by 7 and 13, because 1001, the factors of 1001 are 13, 11 and 7. I already told you that if a number n is divisible by k, then n is also divisible by each and every factor of k. So simply, if any number n is divisible by 1001, then that number n will also be divisible by each and every factor of 1001. That is, that number n will also be divisible by 7, 13 and 11. So the point is that I am going to understand the combined divisibility rule of 7, 11, 13 by understanding the divisibility rule of this 1001. Now there is no particular divisibility rule of 1001. What I am going to do it that we are going to make some simple applications of remainders in this thing. Now suppose there is a number ABC. What is this number? This is a specific case, what I am telling here, and after this I am going to tell you a general case. Now in this specific case, I have taken a 3-digit number ABC, and I am going to multiply this 3-digit number ABC by 1001. So I will multiply it by 1001. Now after multiplying this digit ABC by 1001, I know that I am multiplying this ABC by 1001, and 1001 is divisible by the three numbers, the three prime numbers 7, 11 and 13. So this number is automatically divisible by 7, 11 and 13. Now, what is this equals to? This is equals to ABC, ABC. I have multiplied this 3-digit number ABC by 1001. What I got? ABC, ABC. That is two triplets in a row. This is what I got. So these are two triplets in a row, and these two triplets, this number is same as this number. If this number is divisible by 7, 11 and 13, then this number is also divisible by 7, 11 and 13. So this is the case. So if you find two same triplets anywhere repeating themselves twice, if you find two same triplets anywhere repeating themselves twice, then you will be able to say that these two triplets placed one after other will be divisible by 7, will be divisible by 11, will be divisible by 13. This is the whole point here. I hope you are getting my point. This is how things are taken in this thing. Suppose there is a number 8, 3, 6, 8, 3, 6. Now 8, 3, 6, 8, 3, 6. These two triplets are repeating themselves twice. So this number will also be divisible by 7, also be divisible by 11, also be divisible by 13. Okay? 8, 3, 6, 8, 3, 6, divisible by 7, divisible by 11, divisible by 13. ABC, two triplets repeating themselves one after the other. So this was a specific case, that if two triplets are repeating themselves one after the other, then they will be divisible by 1001, and if they will be divisible by 1001, then they will also be divisible by 7, 11 and 13. Now coming to a more general case, and this one is an important one. Discussing the general case. Suppose there is a number A, B, C, D, E, F. This is a 6-digit number. How can I write this digit as? I can write this digit as A, B, C into 1000 plus D, E, F. This is how I can write this number. I wrote this number A, B, C, D, E, F as A, B, C into 1000 plus D, E, F. Now I am going to check the divisibility of this number ABC into 1000 plus DEF by say 7. Okay, I have to check the divisibility of this number by 7. So I am going to check divisibility rule of these individually. What is the divisibility for the remainder when 1000 will be divided by 7? 7, let us divide it. I divide 1000 by 7. 7 on the 7, 3, 7 for the 28, 2, 7 to the 14, 6 is the remainder. So we can say that when this 1000 is divided by 7, the remainder is 6. Or we can say that the remainder will be minus 1. Same things. Okay. 6 is equivalent to minus 1 because I can write this 1000 as 7 into 142 plus 6, and I can also write this 1000 as 7 into 143 minus 1. That is 7 into 142 plus 6 and 7 into 143 minus 1. These both values are equal to 1000. So this 6 is equivalent to minus 1 when it comes to dealing with remainders. So this effectively comes out as 6 and minus 1. And suppose this ABC is divided by 7, I do not know the remainder, so I keep it in a standby, and this DEF. Some remainder will come and DEF will be divided by 7. So I do not know exactly what will be the remainder when DEF will be divided by 7, and I do not know what will be the remainder when ABC will be divided by 7, but I got the remainder here as minus 1. So whatever the remainder is going to be between ABC into 1000, I am going to multiply this 1000, this ABC by this remainder 6. So if I am going to multiply this ABC by the remainder that is left when 1000 divided by 7, so the remainder is left here is 6, or we can also say it as minus 1. So what I am going to do is that I am going to multiply this ABC by minus 1, because minus 1 is also a remainder here. When it comes to the dealing with these sort of quotients and remainders, I can use the case of negative remainders. That is the concept of negative remainders. I told you this in the previous video lecture. So here, the remainder when 1000 is divided by 7 is 6, or we can also say that the remainder when 1000 is divided by 7 is minus 1. So I am going to multiply this minus 1 by ABC. So what I am going to get? I am going to get minus of ABC. And what is this? Plus DEF. So whatever number I am going to get by this thing, minus of ABC plus DEF, if this number will be divisible by 7, then the whole number ABC, DEF will be also divisible by 7. This is the point here. If this number minus of ABC plus DEF is divisible by 7, then the original number ABC DEF will also be divisible by 7. And if we have to find out the remainder when ABC DEF is divided by 7, then the respective difference of minus of ABC plus DEF, that is a summation of minus of ABC, that is negative of plus 3 digits, and addition of positive of last 3 digits, whatever will be left, whatever will be the remainder when this quantity will be divided by 7, that remainder will be equivalent to the remainder which we will obtain when we will divide this 6-digit number ABC DEF by 7. This is the logic here. The logic is same for the remainders, the logic is same for the divisibility, because remainders is an outcome of divisibility only. Here, the only typical thing, the only USAR different thing to understand is that this 1000 when divided by 7 leaves a remainder of 6, and this 1000 when divided by 7 will also leave a remainder of -1. So you need to understand that in this scenario, this 6 is equivalent to -1. This is what you need to understand here. I hope you are getting my point up to a bit. Next point, I can write this number as ABC into 1000 plus DEF. Now I divide by 11. Now I'm checking the divisibility of this number by 11. What I'm going to get? If I divide this 1000 by 11, 11 into 90 is 990. So the remainder will be 10 or -1. Because you can write this 1000 as 11 into 11 into 90 plus 10, or 11 into 91 minus 1. Both the things are the same things. Now, this 1000 when divided by 11 leaves a remainder of 10, or it leaves a remainder of -1 in the concept of negative remainders. So when this -1 will be multiplied by ABC, it will become minus of ABC. So it will become something like this: minus of ABC plus of DEF divisible by 11. So the point here is that if this quantity minus of ABC plus of DEF is divisible by 11, then I will say that this whole 6-digit number ABC DEF will be divisible by 11. If this quantity ABC DEF is divisible by 11, then this quantity minus of ABC plus DEF will also be divisible by 7. And if I have to calculate the remainder which this 6-digit number ABC DEF will leave when they are divided by 11, that remainder will be equivalent to the remainder which we will get when minus of ABC plus DEF will be divided by 11. So the remainder in this case will be remainder in this case. That is, the remainder of minus of ABC plus DEF by 11 will be equivalent to the remainder when this 6-digit number ABC DEF is divided by 11. So this is the point. So in the case of 7, in the case of 11, what was the logic? Here, when 1000 divided by 7, remainder is -1. When 1000 divided by 11, remainder is -1. But the concept of negative remainders is a lifesaver here. Next thing. Next. ABC into 1000. Check the divisibility of 1000 by 13. You add 13, 91, 12. So the remainder when this 1000 is divided by 13 is 12. So, and in the concept of negative remainders, we can say that when this 1000 is divided by 13, I will get the remainder as -1. So when this 1000 divided by 13, the remainder, original remainder is 12, and when this 1000 divided by 13, the concept of, by going by the concept of negative remainders, the remainder is -1. Now this is ABC. This ABC will be multiplied by this -1, the same logic which we have been following in the last two cases. And when this ABC is multiplied by -1, what I will get? Minus of ABC. So I will write here as minus of ABC plus of DEF divided by 13. So, if this quantity minus of ABC plus DEF is divisible by 13, then this whole 6-digit number, that is this one, I write it here again, I have to erased it, DEF, this number, 6-digit number, ABC DEF, will be also be divisible by 13. This is the logic. Then if I have to check the divisibility rule of this 6-digit number, ABCDEF by 13, What I do? Negative of first three digits, that is minus of ABC, and positive of last three digits, plus of DEF. The summation of the result of these two things, if they are divisible by 13, then the original number is also divisible by 13. And if I have to find out what will be the remainder when this 6-digit number ABCDDEF is divided by 13, that remainder will be equivalent to the remainder that we will find by dividing minus of ABC plus DEF by 13. That is, remainder of ABC DEF by 13 will be equal to the remainder of minus ABC plus DEF by 13. Now friends, okay, first write it down, then I am going to explain this to you in a bit brief manner. I hope that I have make it understood to you, going by the whole concepts and going by factorizing these things. I have made this thing very much clear to you in a very clear way. So I think that this thing that should not be that much difficult for you. This is my thought. And obviously, minus 1 concept, I can write this 1000 as 13 into 76 plus 12, or 13 into 77 minus 1. So the friends, in brief, I will like to brief this whole thing once again to you. What was this whole thing saying? This whole thing was saying something like this, that this was the divisibility rule of 7, 11 and 13 in conjugation. Now the very point that why this divisibility rule was useful and why this divisibility rule came out in this way is because of the fact that 7, 11 and 13 are prime numbers. And by multiplying a prime number, I got a number which is one more than the which is 1 more than 10 to the power cube, that is 1000. That is, I got 7 into 11 into 13 as 1001. So 1001 is going to give me triplets of a particular order. I told you the specific case in the first case. In that specific case, if any 3-digit number, that is in the first specific case, if any 3-digit number is multiplied by 1001, I will get that 3-digit, that is that triplet written twice, one after the other. That is, if I am going to multiply 534 by 1001, I am going to get 534, 534. That is 534 and 534 are written in pairs, one after the another. So this becomes divisible by 1001. So this is the whole logic here. You need to understand this thing in this way. That is when we are going to look at the divisibility from the point of 1001. Then in that case, if I found any triplet written twice, that is 834, 834, twice it is written, that means this number 834, 834 will be divisible by 7 also, it will be divisible by 11 also, and it will be divisible by 13 also. If I find it 895, 895, then two triplets, 895 is one triplet, 895 is another triplet, the same triplets are repeating themselves, that is, they are a multiple of 1001. And by saying that they are a multiple of 1001, they are also a multiple of 7, they are also a multiple of 11, and they are also a multiple of 13. So any two triplets that are written one after another, they will be divisible by 1001. This thing will be very first, it should be very much clear to you in your mind. Next was a general case. In this case, I have derived a specific set of formula, or you can say a specific set of way, which will be very much useful for you when dealing with the divisibility of 7, 11 and 13. So this method of the divisibility of 7, 11 and 13, this is much more useful than the methods that we find in books. In the book there is one more method of 7 which is not of that much use. And in the books, the reason of applying that method is also not given. I am going to explain that reason to you here, how this method is being applied. But the point here is that this method is very much useful when it comes to the divisibility rule of 7, 11 and 13. That is, in a 6-digit number, I took the first 3 digits in the negative form and the last 3 digits in the positive form. Add them, and I found that if the resulting number is divisible by 7, then the original number is also divisible by 7. If the resulting number is divisible by 11, original number is also divisible by 11, and the resulting number is divisible by 13, original number is also divisible by 13. That is, on what quantity it depended? It depended on this quantity, minus of ABC plus of DA. 7, 11 and 13. All three are continuously useful in it. Now one thing would be coming in your mind, that why I have taken this thing only in the case of 6-digit numbers. Why not a 7-digit number? What I'm saying why I have taken this case only in case of 6-digit number. Why I have not taken this case in case of 7-digit numbers. So when I'm going to take this case in 7-digit number, it is also that much easy only. You have to just need to understand the concept. The way of dealing with these sort of questions when it comes to the divisibility of 7, 11 and 13 in the combined form in a 7-digit number or a 8-digit number or a 9-digit number or a 10-digit number, just analyze it a bit. Do a bit of R&D at your home, that how I'm going to apply this particular method of the combined divisibility rule of 7, 11, 13 and 7-digit numbers, 8-digit numbers, 9-digit numbers, 10-digit numbers. Do it by yourself. And in the next video lecture, I'm going to tell you how you're going to deal with the questions which involves the involvement of 7-digit numbers or 8-digit numbers. However, normally these such big numbers will not be seen. But if they are there, we must be ready for them. The most difficult paper of CAT, we are going to be ready for it. When it comes to the quantitative aptitude and logical reasoning section, English is up to you. So friends, thank you for watching my video lectures. I hope this lecture was helpful to you. I will meet you soon in my next video lecture. Thank you.